planet that did not exist managed to trap the most trusted scientific minds on Earth for more than half a century. The calculations were perfect. The observations kept confirming the prediction. And across observatories around the world, astronomers repeatedly watched the same impossible image unfold. A tiny black dot moving across the surface of the sun. By the late 1800s, textbooks, observatories, and some of the most respected scientists alive had accepted a dangerous conclusion. There was another planet inside Mercury's orbit, hidden dangerously close to the sun. And they were all wrong. Because 56 years later, Albert Einstein would prove that the object humanity had spent decades chasing had never existed at all. The black dot crossing the sun had been real. The calculations had been real. The observations had been real. But reality itself had never matched what scientists thought they were seeing. And what happened next permanently exposed one of science's most dangerous weaknesses. Sometimes evidence appears only because enough people expect it to exist. The crisis started with a problem no one could solve. In 1859, French mathematician Urbain Le Verrier noticed something disturbing inside the orbit of Mercury. Mercury was not moving correctly. Its orbit shifted very slightly during every revolution around the sun. Not enough to notice casually, but enough to create a serious mathematical problem. According to Isaac Newton's laws, Mercury's path should have behaved predictably. Instead, the planet's closest point to the sun kept drifting by a tiny amount every single orbit. Around 43 arc-seconds per century. A tiny error. But in astronomy, tiny errors become enormous problems. Le Verrier had already become famous years earlier for something extraordinary. He had predicted the existence of Neptune using mathematics alone. No telescope had found Neptune first. His equations had. Astronomers pointed telescopes exactly where his calculations predicted. And Neptune was sitting there, waiting. It was one of the greatest scientific victories of the century. So when Le Verrier announced another prediction in 1859, nobody doubted him. If Mercury's orbit was drifting, there had to be another planet pulling on it. Invisible. Extremely close to the sun. He even gave it a name. Vulcan. And suddenly, the hunt began. Observatories across Europe immediately started watching the sun. The problem was brutal. Any planet orbiting closer than Mercury would spend most of its time hidden inside the sun's overwhelming brightness. It could only be seen briefly during a transit. A tiny black silhouette crossing the giant burning solar disk. Minutes of visibility. Maybe less. Miss it once, and the opportunity vanished. Then the first confirmation arrived. Later that same year, an amateur astronomer named Edmond Lescarbault reported seeing exactly what Le Verrier predicted. A small black object crossing the sun. He had sketched the transit by hand. Le Verrier personally traveled across France to examine the report. He questioned Lescarbault for hours, checked the timing, verified the calculations, then announced publicly that Vulcan had been found. And the entire scientific world accepted it immediately. That tiny black dot crossing the sun had now become proof. Except something strange happened next. Nobody could reliably find Vulcan again. Astronomers kept searching. Weeks passed. Nothing. Months passed. Still nothing. Then suddenly, another observer would report a transit. Another tiny black silhouette. Another confirmation. The image kept returning. Just enough to keep belief alive. And this was where reality first started pulling away from prediction. If Vulcan existed, its orbit should have been measurable. Its transit should have become predictable. But every new observation created chaos. Different astronomers reported different orbital paths, different transit times, different speeds. Some claimed Vulcan had moons. Others claimed there were multiple Vulcans. Not one planet. An entire ring of small bodies orbiting near the sun. But none of the calculations matched each other. The black dot kept appearing, but every attempt to predict its next appearance failed. And that should have ended the story. It did not. Because the repeated sightings created something far more powerful than evidence. Collective belief. By the 1870s, major observatories around the world had accepted Vulcan as real. Scientific journals discussed it openly. Astronomers published orbital models. Maps were drafted. Predictions were circulated internationally. An invisible planet had quietly become accepted scientific truth. And here is where the danger became much larger than one missing planet. This was no longer about Vulcan. It was about Newton himself. For nearly 200 years, Newtonian gravity had explained the universe perfectly. Planets moved exactly as predicted. Comets followed known trajectories. The equations worked everywhere. Except Mercury. If Vulcan was not causing Mercury's orbital drift, then something much worse was happening. Newton's laws were failing near the sun, and nobody wanted to believe that. So astronomers kept looking harder. Year after year. Solar eclipse expeditions were organized worldwide. Teams carried fragile telescopes across deserts and mountaintops. Because during a total eclipse, the sun's glare disappeared briefly. For a few precious minutes, Vulcan should become visible. Again and again they searched. Again and again reports arrived. Tiny dark objects near the sun. Possible confirmations. Possible transits. Possible sightings. The same visual anchor kept returning. That tiny black silhouette crossing the massive glowing sun. Except every new sighting made the problem worse. The orbital calculations still refused to stabilize. No two observations fully matched. The objects seemed to obey no predictable pattern. But after decades of reports, abandoning Vulcan had become impossible. Too many respected astronomers had seen it. Too many papers had been published. Too much authority was invested. The scientific system itself had become trapped. And then, in 1915, a young physicist working in Germany destroyed the entire structure. Albert Einstein was not searching for Vulcan. He was trying to solve something much bigger. Gravity itself. For centuries, gravity had been treated as a force pulling objects together. Einstein proposed something radically different. Mass was bending space itself. Gravity was not a force. It was geometry. And when Einstein finished his equations for general relativity, he tested them against Mercury. The exact same orbital drift that had haunted astronomers for 50 years. 43 arcseconds per century. The number matched perfectly. Exactly. No hidden planet required. No Vulcan. No unseen gravitational tug. Mercury had never been behaving strangely. Newton's equations had simply stopped working correctly near the sun's immense gravity. And instantly, 50 years of scientific certainty collapsed. Every telescope sketch. Every transit report. Every published orbital model. Every claimed sighting. Wrong. But the most unsettling part came when astronomers reviewed those famous observations. The black dots crossing the sun had not all been fraud. Some were probably sunspots, temporary dark regions moving across the solar surface. Some were instrument errors, dust particles inside telescopes, optical distortions. And some sightings likely came from something far more dangerous. Expectation. Scientists were so certain Vulcan existed that normal imperfections started looking like confirmation. The human brain quietly filled in the missing evidence. The same black dot crossing the sun kept appearing, but the meaning changed every time. At first it meant discovery, then confirmation, then proof, then scientific authority, and finally something much more uncomfortable. It meant thousands of intelligent observers had spent decades reinforcing a false reality because enough people already believed it was true. Vulcan never existed, but entire generations of science acted as if it did. And that tiny silhouette crossing the sun now carries a completely different meaning. It is no longer evidence of discovery. It is evidence that even science can become trapped by expectation. Sometimes the measurement is not wrong. Sometimes belief changes what people think they measured. The ghost was never in space. It was in the observer.